Principal components analysis. Principal components analysis is a dimensionality reduction scheme used to reduce the dimension of a data set. This technique simplifies the data, letting you see the trends more clearly, and is great for making machine learning algorithms run faster. So how this works, is that if you have a data set, you find the orthogonal eigenvectors of unit length that best explains the variance of the data set you are given. Alongside these, the corresponding eigenvalues are given, determining the length of the vector, or the amount of variance in that particular degree of freedom. By sorting the vector value pairs in decreasing order, and picking out the first k, we have reduced the data set to k degrees of freedom. A rule of thumb is to choose the amount of eigenvectors that counts for 99% of the total variance. Let's take a look at an easy example. We start by looking at these points on a 2D plane. The first thing we want to do is finding the first principal component. That is the direction which gives us the most variance. Let us now project our points onto the first principal component. This will give us this line. What this achieves is that we reduce our two-dimensional dataset to one dimension. This will however lead to some loss of information. In many cases the important trends of the data is still conserved. To find the second principal component, we choose the line that is orthogonal to the first one. Then we maximize the variance in the data that is not captured by the first principal component. In our case this will be the second principal component. If we use principal component analysis on our dataset and project our points on the first two principal components, no information is lost. By rotating the data, we can represent our dataset in the axis of the principal components. An example of a real-world application of principal components analysis is that of facial recognition. The technology is used by police, forensic scientists, governments, private companies, the military, and casinos. Even though algorithms used by the software tools are proprietary and are secret, the most common methods used are eigenfaces, which are based on principal component analysis to extract face features. There are the following two types of applications of PCA and face recognition. 1. Face recognition, identification. In this, the input to the system is the image of a face, and the system reports the decided identity of the person on the basis of database of known individuals. This can be used to identify criminals. 2. Face verification. Here, the system confirms or rejects the claimed identity according to the input face image. It is for instance used by companies to grant people access to buildings. Thank you for watching.